Welcome to Spring LIB.
So in this problem, we are asked to find the molecular geometry and electron pair geometry of each of the following molecules or polyatomic ions. So we'll first have to draw the Lewis structure. In order to do that, find the number of valence electrons. So for example, for IF6, we have 6 fluorines and 1 iodine. Each of these contributes 7 valence electrons. So 7 times 7 is 49. If there's a charge of positive 1, we have to subtract 1, and we get 48 total valence electrons. Then count the valence electrons in the Lewis structure to make sure it matches. So we have 1, 2, 3, 4, 5, 6 of the valence electrons being used because we have 8 around each of the fluorines, and then we're not counting the ones around the iodine twice. So we do 6 times 8, that's 48, so that's correct, and it's going to look like that. Iodine can expand its valence, and we can take a look at the chart here to see what kind of geometry that is. We see that is octahedral. So this is octahedral geometry. So we move over here, and this is carbon tetrafluoride. So if you take a look at that, you will recognize that as tetrahedral because we have 4 bonds to the center atom. So that's tetrahedral. There are no lone pairs on the center atom, so we just consider it tetrahedral. So then we have boron trifluoride. So boron trifluoride is trigonoplanar. The reason is because boron does not have more than 3 bonds in this molecule. So boron is an element that can only form 3 bonds, and therefore it's only going to form 3 bonds to the fluorines, and therefore it's trigonoplanar, and the angle here would be 120 degrees. So for the next one, if you take a look at this, this is just a calculation for the Lewis structure. So remember to add 1 to the electron count because it has a -1 charge. Silicon will be in the center, and we have 5 of the atoms attached to it. So this is called trigonal bipyramidal. So the reason is because we have 3 here on the bottom. The base here is a triangle, and then we basically have a pyramid with a triangular base on top, and then we have another one that's the same thing on the bottom. That's why we call it trigonal bipyramidal, because there are 2 pyramids with a triangular base. So the next one, this one is just linear. So beryllium can only form 2 bonds, and is going to form 2 bonds to the chlorines, and it's just going to be a linear molecule like that.